All right, so far in Java, we've seen many different data types, and one of the most popular one is a data type just to represent, just to represent an integer. So like 7 or -5. So that would be the int data type, and that's a primitive data type. It's not an object data type. We also have data types for decimal numbers. So if I had 3.7 or -2.8561. And so, of course, this is the double data type, another primitive type. Okay. Um, so once again, what is a primitive type? Just as a refresher, well, if I make a variable int x equals, let's say 7, so this in RAM, this creates a storage space called x, and we're going to put 7 inside of it. But then that's it. A primitive variable can only store data. So you can't call methods. You can't say x dot anything. You can't say x dot length. Like what that's what you can do with strings. You can't say x dot get num. So you can't call any methods. You can basically just print these variables. You can print them. You can use them in calculations. You can use them in if statements. All right, but not much more you can do with primitive types other than just store a single value inside that space. Okay, so we've got data types for ints, we got data types for double, but what we don't have in Java, we don't have a primitive data type for a fraction. Like, what if I wanted to store 1/3? Um, well, you might say, well, you could just write that as a decimal, 0.33333, but that would not be an exact value. So it would have, I think, 15 threes, but then it would be cut off and it wouldn't be exact. So if I wanted to store exactly the value 1/3, there is no existing primitive data type to allow us to do this. So what we're going to do is create our own data type. We're going to create an object data type called rational. So you've probably in math class heard the word rational. Basically, just think of rational as a fraction. But a rational specifically is a ratio of two integers, right? So whenever you have an integer divided by another integer, that is called a rational value. So we're going to create an object that is a rational. So remember, objects have a reference pointing to an object. So let's just pretend this is called R, or R1. So how would we implement this? How would a rational look? Well, you may have guessed it. It's just simply going to have two int values stored within the object. And we can call the first one num for numerator, and call the second one den for denominator. And then this would just store 1 and 3. And so that's how this example would look in RAM. Okay, so we're going to create a class called rational that will just have two instance variables, a numerator and a denominator, and they will both be integers. All right, so let's do a little bit of this together here. So I'm going to create a new class called rational. And let's just fix this up here. Okay, so first we start with the class header. Okay, and next we write the instance variables, also called fields. And these are going to be private, and they're both going to be ints. So we're going to have a numerator and a denominator. Okay, and then we're going to have our constructor. So this is a public method that does not have a return type, not even void, and the name of the constructor must match the name of the class. So this is going to be public rational. And then the parameters, usually the parameters are going to represent every one of your instance variables. So we're going to create two ints. I'm just going to call them n and d. And these are values that are going to be passed in from another class, from the client class. They're going to be plugged into here. What am I going to do with them? Well, I'm going to plug them into num and den, my instance variables. So I'm going to reassign the numerator to n, and I'm going to reassign denominator to d. Okay. Compile that. Okay, and now at this point, I should actually, just with this simple code, I should be able now to create a rational object in another class. So let's just pause this, and I'm going to go and create a new class. Let's call it rational tester. So this is my client. Okay. And in here, this is where I'm going to create a main method. So this, I'm actually going to run this class. Okay, but now I can do something like this. I can say, let's create a rational reference. I'll call it, let's call it R1. And so that right there, you can actually put a semicolon. And what that does in RAM is it creates a reference. Let me just get this kind of split screen here. So, oops, if I go back to, where is it now? Rational tester. So that will create in RAM, that will create just a little reference called R1. All right, but if I want to actually create the object, I'm going to assign this to a new rational, and then I don't do 1/3 like this. I pass them in like I'm calling a method. So 1, 3. So this will be the numerator, and this will be the denominator. So once again, whenever you say the new keyword, you are calling the constructor method, and you're passing these in as parameters. So the 1 gets passed into n over here, and the 3 gets passed into d over here. And so they get plugged into these values. So what does that look like in RAM? Well, it creates a new object that has 2 int values. So num is going to be 1, and den is going to be 3. Okay, so I should be able to compile this. Yeah, no problem. Now, so you should know all this. One thing that we haven't discussed yet is creating something called a default constructor. So let's go back to the rational class. So I can create as many constructors as I want. So this is called overloading your constructor. So I have the same header here, public rational, but I'm going to have a different parameter list. So in order for this to work, in order for me to kind of overload a constructor, I need to have a different parameter list. So I'm just going to have no parameters. And this, whenever you do this, this is called a default constructor. And this actually is very common when creating objects. We haven't done this yet, but many class templates that people create contain a default constructor. Now, what is the purpose of a default constructor? Well, it basically just assigns num and den to whatever default values you want, like let's say just 1 and 1. So that gives me a rational number of 1 over 1. Now, how would I use this? How would I call this? Well, if I went to my tester over here, I could say rational R2 equals new rational, and then just put no parameters. So there are some rare cases where you might want to create a rational object, but you don't know these values yet. Perhaps they're going to be created randomly. Perhaps they're going to be entered by the user. So we may not know the values yet, but we still want to create an object for like a placeholder or something. So this gives you the ability to do that. By creating a default constructor, we can now build a new rational object this way. So then in RAM, we're now going to have a second reference pointing to a rational object, and this is just going to be 1 and 1. Okay, and then you could keep going. You could build a whole bunch. I'm gonna make R3. You could even create, I'm not going to do it, but you could create another constructor that just has one parameter, and maybe that's just the numerator, and then it automatically sets the denominator to 1. So you could do that as well. But I'm going to make one that is, let's do 1/2. Actually, let's do 3/2. Okay, so then in RAM, that creates a reference called R3, pointing to an object storing 3 for the numerator and 2 for the denominator. Okay, then the next thing you always want to do is to create accessors and mutator methods. Okay, so public int get num, and this is simply going to just return the numerator. Oh, at this point, I might as well show you something else that is common. Not everyone does this, not everyone likes it, but what you sometimes see with accessors and mutators is people bringing this brace up to the end, and then also bringing this code up to here, and then also bringing this code up to here. And so what you have now is a method that is just all in one line, and it's kind of deceiving a little bit. You look at that one line, you don't instantly think that it's a method, but it is because of these braces. So if you would like to do this just to save space, you can do that as well. So I can make another accessor called getDen, and this just returns the denominator. Okay. A lot of people are freaked out by these, and they don't like it. So if you just want to write it the traditional way, you can do that as well. So then mutators. So I'm going to make a void method called setNumerator, and that is going to, here, let me do it the traditional way here. This is simply, this is going to take in a parameter, which I'll call n, and it's going to reassign the numerator to n. Okay, so this method allows you to change the numerator of one of your objects kind of on the fly. And then I'll do it again for set denominator. Okay, once again, you could crunch these methods into one line, kind of like what we did up here. Yeah, and if you're searching the internet and you look at other classes that people have made, you'll find that often, the one line method. Okay, so the other thing we need to make is a toString method. So once again, remember where I am right now. I'm in the rational class. So this is just my definition. This just defines what a rational is. We don't have a main method. We can't run this. We're just defining all the methods that a rational object can have. So we're going to make a toString method, and this is just going to return the numerator concatenated with a slash concatenated with the denominator. So we're just going to return it as kind of like a fraction. So a number and then a slash and then the denominator. All right, so let's have a look. If I go back to my tester, and if I print R1, so R1 has a numerator of 1 and a denominator of 3. So if I compile and run this, it's popping up on my second screen here. It gives me 1/3. Okay, perfect. Looks like a fraction. I can even let's test something out here. What if I said R1 dot set denominator to 4? All right, so what that is going to do is it's going to change your denominator here. It's going to change it to 4. Okay, so it does that kind of behind the scenes in RAM, and then I'm printing R1, so now it should print 1/4. Okay, so hopefully all of this is making sense and nothing super new here. Yeah, so now it prints 1/4. Okay. You can also, if you don't want to print the whole fraction, you can just print r1 dot get numerator. So then this will just print the numerator of r1, which would be right here. That would be, it'd be 1. Okay, so onward to bigger things with this rational class. We're going to do kind of many things with this rational class. The first thing that would be awesome to make is a reduce method. Okay, let me explain. So let's say somebody makes a rational, and let's just pretend they put 10 and 15. Okay, so if I were to print R4 right now, it would print 10 and then slash 15. But wouldn't it be nice to make a reduce method? So I could say R4 dot reduce, and so this is a void method. And then if I printed R4, it'd be awesome if it reduced it. So 10 over 15 reduces to 2/3. So it'd be great if it printed 2/3. So what we want to do is build a reduce method that takes no parameters. So you don't have to pass any parameters in, but you do have to put a reference before. So one of these rational references we want to put first, and then we're going to say dot reduce. And so this procedure method is going to actually change the numerator and denominator so that it's in reduced form. So to do that, we're going to go back to our rational class, and I'm going to do it up here. I always like to have my toString as the very last method, so I'm going to sneak it right in here. Public void reduce, and it takes no parameters, but this is going to reduce this object's numerator and denominator into lowest form. Okay, so think about how we're going to do that. If I have, let me just draw R4 over here. If I have R4, and right now its numerator is 10 and the denominator is 15. So how would I reduce that? Well, what we could do is find the greatest common factor of 10 and 15. So find the GCF of numerator and denominator, and then divide the numerator and denominator by the GCF. So in this example here, the GCF of 10 and 15 is 5, right? So then I just divide each of these by 5, and then there we go. We're done. We have the lowest terms. So we're going to make a little helper method here called GCF. And this will take in two values. I'm just going to call them x and y. And this is going to determine the greatest common factor of x and y. Okay, so we're going to come back to this. Okay, so this method returns the greatest common factor of x and y. So let's pretend we have this done. If we have this method done, then up here I can just calculate the GCF. I'll just call it G. So this is going to be the GCF of numerator and denominator. Okay, again, what are these values? These are the values built into the object. Okay, so it could be 10 and 15, or it could be 3 and 2, it could be 1 and 4. So which one is it? Well, it's going to represent the values that called this method in the first place. So if I go back to my tester, notice I'm saying R4.reduce. So because R4 is calling this method, that means num and den are going to be R4's numerator and denominator. So in this case, that would be 10 and 15. So if I could calculate the GCF and store that into G, then all I'd have to do is divide numerator and denominator by G. And I can do I can do it just like this. Or, you could do it this way too. Num equals, or sorry, den equals den divided by g. That also works, but I'll use a self-assignment operator here. So this basically just divides num by this amount and then reassigns that to num. Okay, then that's it. You don't have to return anything. You're literally just changing num. You know what? Maybe just to avoid confusion, I'm going to change this to kind of the longer way. So what I'm reassigning numerator to this value, and I'm reassigning my denominator to this value. Okay, so now the big task here is completing the GCF method. So I think we've done this before. So we're going to have two values, and I just called them x and y. I mean, you can call these a and b, call them whatever you want. And I'm going to find the greatest common factor. Okay, so what you can do here, I'm going to make a variable. Let's call it result. Okay, and what you should do is start at the lower of x and y. So if x is less than y, then result will be x. Otherwise, actually, sorry, it's not going to work. Let's declare the variable up here, and then I'm just going to assign it in the if statement. Why am I doing this? Well, if you create a variable inside an if statement, then that variable only exists in that if statement. You can't use it outside of the if statement. So I'm declaring the variable before the if statement, and then I'm going to assign it in the if statement here. So I'm just making this variable result be the lower of x and y. So in my example, it would be 10. Okay. Then we just build a loop. And I'm going to say while x mod result is not equal to 0, or y mod result is not equal to 0. Okay, so if one of these things is true, in other words, if one of them is not divisible, then I'm going to continue my loop. And what am I going to do? I'm simply just going to subtract 1 from result. Okay, and then I'm going to return result. So basically this loop, so this value starts at the lower, so it starts at 10, and then it goes down to 9, 8, 7, 6, 5, and then when it gets to 5, both of these are going to be false. And so then that will stop my loop, and then result should be 5. Okay. Now, where am I returning this to? Well, in this case, I'm returning it back to this method reduce. Okay. And then I'm dividing numerator and denominator by that value. Okay, so I'm going to compile this. Forgot a semicolon there. Okay, let's see if it worked. So I'm going to go back to my tester. And let's see if this actually works. So I'm calling the reduce method, and then I'm going to print R4. And so instead of saying 10 over 15, it should say 2/3 if everything worked out right. So I'm going to compile, run it, and there we go. It worked, 2/3. Okay, we can try it again. Make this 30 and make this 40. Okay, so that should reduce to 3/4. And there we go. So we have a perfectly working reduce method. It may not be the most efficient. In other words, you might find a more efficient way to do the GCF. In fact, there could be a recursive version I think we looked at. So we'll leave it at this for now in this video. It's getting kind of long. We are going to continue with the rational and do more with the rational class, but we'll do that in the next video. Okay, bye for now.